Let us start our question number 5 on sound. This is a pretty straightforward and interesting question. If you want, you can pause the screen here, solve the question yourself, come back and play the video to tally your answers. And if you are liking the video on this channel, please do not forget to subscribe because it is highly encouraging. So let's start with understanding the question. Draw a straight line from each quantity on the left hand side to a speed on the right hand side which is typical of that quantity. Speed of the sound in gas, as I told you, this is something that you need to remember. Do not take this number for granted. Please do remember it is around 300, 310, 20, 40 or 50 meters per second. 200 and 300 to 350, anything can be your answer. Speed of the sound in solids, it should be in thousands. 1000, 2000, 3000, 4000 depending on the density of the solid. Here the most appropriate number comes out to be 3000. 30,000, 300,000 are way too big a number. So please do ignore them. They are way too big a number. Now B part, explain why sound waves are described as longitudinal. Please do go through my video on understanding transverse and longitudinal wave on the chapter. In the chapter waves to understand how you describe longitudinal. So why the sound waves are longitudinal? Because the air molecules, they vibrate in the same direction as the direction of the travel of the sound. If your sound is moving, if the sound is moving left to right, all the air particles in between in the path of the sound, they are moving to and fro, and this to and fro movement of all the air molecules are parallel to the motion or to the path of the sound. So how do you say? You say that the vibrations of the air molecules is parallel. Parallel is the term which comes because it is a longitudinal wave. The vibration of the air molecules is parallel, or you can say are parallel to the direction of the sound wave. The sound wave, this is your sound wave, left to right, or let me use a different color so as to distinguish. The blue one is your sound wave, left to right, and it is in parallel to the direction of the oscillations or the vibration of the air molecule. Alright, let us come to the C part. Shows how the displacement of the air molecule, the figure here shows how the displacement of the air molecule at an instant of time varies with the distance along the path of the sound wave. So this is your sound wave. It is shown in a sinusoidal form. These kind of patterns are created by oscilloscopes. You can go through the video in the playlist on oscilloscope, how oscilloscope creates. We understand that sound waves are longitudinal wave, but longitudinal wave can also be converted into sinusoidal curves. So this sinusoidal curve, though by the look of it, it does not look like a longitudinal curve, but it is a same thing as your sound wave. So on this figure, sketch two cycles of the sound waves that has a shorter wavelength and a greater amplitude. Shorter wavelength, greater amplitude. Let us draw greater amplitude, or let me use another color of a pen. Higher amplitude, shorter wavelength. Something like this. Alright, makes sense? If you compare the wavelength, it has gone down. Earlier the wavelength was something quite big. Earlier this wavelength was quite big. Compare the new wavelength. Compare them, wavelength has gone down. The amplitude has gone up. This is the new amplitude. Earlier amplitude was a lower amplitude. So you are done with this question. Sketch 2 cycles. They just asked for 2 cycles and we made so many. We could have just done 2 cycles of sound wave that has a shorter wavelength and a greater amplitude. Suggest 2 changes in the sound heard from this wave compared to the original. Amplitude has gone up. So what happens to the loudness? Greater loudness. Or you can say loudness will increase. More, the sound wave is more loud and it will be of higher pitch. Why? Because the frequency has gone up. Look at the waves. More number of waves present in the same space. Higher pitch, high frequency, that's why higher pitch, more loudness. Why? Because more is the amplitude. So this was an easy question, but I'll show you the mark scheme for you all to tally your answers on question number 5. Have a look at the mark scheme and understand how the mark scheme works. In the next video, we'll be taking up question number 6.